Jimmy Backflow presents Backflow Prevention Device Assembly. Test cock flushing. This presentation examines the issues of flushing backflow prevention device assemblies test cocks before or after closing the downstream shutoff valve, DSSV, also known as the number 2 shutoff valve. Test cock flushing removes foreign material from the test cocks that may enter the backflow test kit and impede the accuracy of the test, or lead to erroneous test results. Flushing the test cocks also establishes that water is available to perform the test, and may remove impediments from the check valve's disc or seat in some situations. The chronological sequence of flushing is dependent on the type of backflow prevention assembly. During flushing, precautions should be taken to restrict water discharging to the surrounding area. In addition, health and safety concerns should be followed when flushing the test cocks. Test cocks typically are not equipped with test cock adapters, and must be installed. When replacing test cocks, or installing test cock adapters, use Teflon tape. Backflow Prevention Device Assembly, Flushing Test Cocks. Question: should you flush the test cocks before or after closing the downstream shutoff valve? Answer: it doesn't matter since both practices accomplish the intended purpose. However, there are pros and cons to both approaches. Whatever the approach, managing the water discharging from test cocks is considered a best practice, since each flushing approach has health and safety issues. Concern number 1, location. The test cock flushing process may depend on the location of the backflow prevention device assembly. If the backflow prevention device assembly is installed for service line protection, the water downstream of the second check valve is potable. In this case, flushing the test cocks before or after closing the downstream shutoff valve does not have any health or safety concerns, since the water downstream of the backflow prevention device assembly is potable. Nonetheless, control the discharge. However, the water downstream of a backflow prevention device assembly, installed on the internal plumbing system, or fire system, is not potable, and caution should be taken during the flushing process. Concern number 2, not on service lines. Not closing the downstream shutoff valve before flushing the test cocks on a backflow prevention device assembly, not installed as service line protection, may create a health and safety issue. In this case, the water discharging from test cock 4 is not potable, and considered compromised. On the other hand, only a slight amount of compromised water will discharge out of test cock 4 during the flushing process, if the downstream shutoff valve is closed drip tight before flushing. Additionally, if back pressure is present, closing the downstream shutoff valve drip tight before flushing prevents large quantities of high pressure compromised water from discharging out of test cock 4. In consideration, if the downstream shutoff valve closes, but is not drip tight, a lesser amount of compromised water discharges out of test cock 4 during the flushing process than if the downstream shutoff valve was not closed. Concern number 3, time saver. Flushing the test cocks after closing the downstream shutoff valve may save time testing the RPZ. For example, if water discharges from the relief valve after closing the downstream shutoff valve, the first check valve is not drip tight, and the test is over. Therefore, flushing the test cocks and installing adapters is not necessary for this situation. However, flushing the test cocks before closing the downstream shutoff valve lessens the time the backflow preventer is out of service. Concern number 4, back pressure. Back pressure downstream of the second check valve can cause issues with testing, and may present a health and safety concern during the test cocks flushing. Therefore, assessing back pressure before flushing the test cocks and testing a backflow prevention device assembly is essential, especially when testing a DCVA, and is best accomplished when the downstream shutoff valve is closed. When attaching the pressure gauge to the test cocks, to assess back pressure, caution should be taken to control the water discharge when purging the air from the gauge. Question: if water is constantly discharging from the RPZ relief valve, upon arrival, should you flush the test cocks before closing the downstream shutoff valve? Answer: no. Suppose water is constantly discharging from the relief valve. In that case, the first check valve is not holding drip tight, and the RPZ is in a static state, that is, no downstream demand, or the second check valve is not drip tight, and back pressure is downstream of the second check valve. In this case, the best approach is to close the downstream shutoff valve before flushing the test cocks. This action assesses whether the relief valve discharge results from a failed first or second check valve. Note: a malfunctioning relief valve could be the cause of the discharge. Backflow prevention device assembly, flushing test cocks. Assessing the cause of the relief valve discharge, situation 1. If the relief valve stops discharging after closing the downstream shutoff valve, the second check valve is not drip tight against the back pressure. In addition, since the discharge stopped, the downstream shutoff valve is also drip tight against the back pressure. In this situation, flush the test cocks and continue with the backflow prevention device assembly test. Backflow prevention device assembly, flushing test cocks. Assessing the cause of the relief valve discharge, situation 2. If the relief valve continues to discharge water after closing the downstream shutoff valve, the first check valve is not drip tight. Since it cannot be confirmed that the downstream shutoff valve is drip tight, an additional step should be conducted to ascertain what triggered the relief valve to open. To further assess the situation, open test cock 4. If the relief valve stops discharging or diminishes, the first check valve is not drip tight. In addition, the RPZ is in a static state since the dynamic state, created by opening test cock 4, caused the relief valve discharge to stop. In conclusion, flushing the test cocks is not relevant, since further testing of the RPZ is not attainable, due to the not drip tight first check valve. Backflow prevention device assembly, flushing test cocks. Assessing the cause of the relief valve discharge, situation 3. Suppose the relief valve continues to discharge after closing the downstream shutoff valve and opening test cock 4. The continuing discharge indicates a malfunctioning relief valve, or the downstream shutoff valve, and the second check valve is not drip tight against back pressure. At this point, conduct a back pressure assessment test to eliminate one of the possibilities. If back pressure was not present at test cock 4, the relief valve is malfunctioning. If back pressure is present at test cock 4, the downstream shutoff valve and second check valve are not drip tight against the back pressure, causing the relief valve to discharge. Question: is there a benefit to flushing the test cocks before closing the downstream shutoff valve? Answer: yes. Flushing the test cocks before closing the downstream shutoff valve reduces the time the water stops flowing downstream. Question: is the water discharging out of test cock 4 compromised? Case 1 answer: yes. The water downstream of the second check valve is non-potable and compromised if the backflow prevention device assembly is installed on a fire system or within the internal plumbing system, regardless of whether the downstream shutoff valve is open or closed drip tight, with back pressure present. Case 2 answer: no. The water downstream of the second check valve is potable if the backflow prevention device assembly is installed for service line protection after the meter, regardless of whether the downstream shutoff valve is open, with back pressure present, or closed drip tight. In this arrangement, the water downstream of the second check valve is not compromised if the plumbing system complies with cross-connection control plumbing codes. Consequently, if the plumbing system is not compliant with the cross-connection plumbing codes, and a backflow incident occurs, the water downstream of the second check valve is compromised. Double check valve device assembly, test cock flushing procedure. The procedure for flushing the DCVA test cocks, irrespective of whether the downstream shutoff valve is closed, before or after flushing, is as follows. Open and then close test cock 1, 2, 3, and 4. Note: it is not crucial to flush the DCVA test cocks in a specified order. What's critical is controlling the discharge when flushing the test cocks. DCVA with downstream demand, flushing before closing the DSSV. The check valves are open when the DCVA is in a dynamic state. In this situation, Flushing the test cocks before closing the downstream shutoff valve removes debris and foreign material from the test cocks, but does not exercise the check valves. DCVA with no downstream demand, flushing before closing DSSV. The DCVA check valves are closed when the DCVA is in a static state, due to no downstream demand. In this situation, flushing removes debris and foreign material from the test cocks, exercises the check valves, and may remove impediments from the check valve's disc or seat, on a standstill DCVA. DCVA with downstream demand, flushing after closing DSSV. When the DCVA is in a dynamic state, due to a downstream demand, closing the downstream shutoff valve drip tight, closes the check valves, and puts DCVA in a static state. In this situation, flushing removes debris and foreign material from the test cocks, exercises the check valves, and may remove impediments from the check valve's disc or seat, in some circumstances. DCVA with back pressure, flushing before closing the DSSV. With the downstream shutoff valve open, and back pressure present, the DCVA is in a static state, thus, the check valves are closed. As a result, flushing exercises the first check valve, but not the second check valve, due to the back pressure holding the second check valve closed. In addition, the back pressure may, or may not dissipate, depending on circumstances related to the back pressure, with the flushing of test cock 4. As a result, flushing test cock 4 introduces compromised water into the surrounding area, resulting in possible health and safety matters, a drawback of having the downstream shutoff valve open, during flushing. In this situation, the tester should confine the test cock discharge. Back pressure issues occur on fire line containment or internal protection installations. DCVA with back pressure, flushing after closing DSSV. The DCVA check valves are closed when back pressure is present, and the downstream shutoff valve is open, or closed but not drip tight. Closing the downstream shutoff valve drip tight does not change the position of the check valves. However, closing the downstream shutoff valve drip tight before flushing locks in the back pressure and diminishes the amount of compromised high pressure water that emanates from the flushing of test cock 4. Notwithstanding, controlling water discharge from test cock 4 is still good practice. In addition, removing the high pressure compromised water introduces potable water at test cock 4, thus lessening health and safety concerns, an advantage to closing the downstream shutoff valve before flushing. Back pressure issues occur on fire line containment or internal protection installations. Reduced pressure principle backflow prevention device assembly, test cock flushing procedure. The procedure for flushing the RPZ test cocks, irrespective of whether the downstream shutoff valve is closed before or after flushing, is as follows. Step 1. Open test cock 4, 3, 2, and 1. Step 2. Close test cock 1, 2, 3, and 4. Note, the 4-to-1 flushing method creates a flow situation in the assembly, thus preventing an untimely relief valve discharge. The relief valve is designed not to discharge when the assembly is in a flow state. Flushing the RPZ in this manner is pivotal to the testing outcomes, therefore, conduct the flushing as stated. RPZ with downstream demand, flushing before closing DSSV. The check valves are open when the RPZ is in a dynamic state. Due to the downstream demand, the relief valve will not precipitately discharge during the flushing procedure. However, the 4-to-1 test cock flushing method should still be performed. Since the RPZ is in a flow state, the water discharging out of the test cocks is potable. Nonetheless, control the discharge. A disadvantage of not closing the downstream shutoff valve before flushing, when the RPZ is in a dynamic state, is that the tightness condition of the first check valve is not immediately observed. RPZ with no downstream demand, flushing before closing DSSV. If there is no downstream demand, the RPZ is in a static state, and the check valves are closed. In this case, the first check valve is drip tight, if water is not discharging from the relief valve. Since the RPZ is in a static state, it may not be necessary to close the downstream shutoff valve to perform the operational test of the RPZ. The static state condition is confirmed when the no-flow validation test is performed. In addition, with the RPZ in a static state, the water discharging from the test cocks is potable when back pressure is not present. Note: notwithstanding, perform the 4-to-1 test cock flushing method, which exercises the check valves, and may remove impediments from the disc or seat, on a standstill RPZ, such as those installed on fire systems. RPZ with downstream demand, flushing after closing DSSV. The RPZ check valves are open when there is a downstream demand. Closing the downstream shutoff valve drip tight creates a static state, causing the check valves to close. In addition, since the RPZ is in a static state, and water is not discharging from the relief valve, the first check valve is observed drip tight. A benefit of closing the downstream shutoff valve before flushing. With the RPZ in a no-flow state, and back pressure absent, perform the 4-to-1 test cock flushing method. The water discharging out of the test cocks during flushing is potable. Nonetheless, control the discharge. RPZ with back pressure, flushing before closing DSSV. The RPZ is in a static state when back pressure is present, and the downstream shutoff valve is open, or closed, but not drip tight. In a static state, the check valves are closed. Subsequently, the 4-to-1 test cock flushing method does not create a flow condition, since the back pressure is holding the second check valve closed. In addition, the water discharging from test cock 4 is compromised, which may, or may not dissipate, depending on circumstances related to the back pressure, during the flushing of test cock 4. Consequently, flushing before closing the downstream shutoff valve may lead to health and safety issues. This situation is typical on fire line containment or internal protection installations. RPZ with back pressure, flushing after closing DSSV. The RPZ check valves are closed when back pressure is present. The back pressure creates a static state. Closing the downstream shutoff valve drip tight keeps the check valves closed, and locks in the back pressure downstream of the second check valve. Consequently, the 4-to-1 test cock flushing method removes the compromised high-pressure water downstream of the second check valve, and introduces potable water at test cock 4, thus creating a flow condition, a benefit of closing the downstream shutoff valve drip tight, before flushing when back pressure is present. With the downstream shutoff valve closed drip tight, the amount of compromised water emanating from test cock 4 is curtailed. Nonetheless, control the discharge. This situation is typical on fire line containment or internal protection installations. Conclusion. Closing the downstream shutoff valve before flushing the test cocks is encouraged over flushing before closing the downstream shutoff valve, for reasons previously mentioned. For instance, if back pressure is present, and the downstream shutoff valve is not closed, or closed but not drip tight, substantial amounts of compromised water may discharge from test cock 4. Conversely, only a small amount of compromised water discharges from test cock 4, if the downstream shutoff valve is closed drip tight, before flushing. Whichever technique is used, control the discharge from the test cocks, during the flushing process, by connecting a clear hose to the test cocks, with the discharge end placed in a bucket, or suitable receptacle. This step prevents compromised water from discharging into the surrounding area, thus lessening health and safety concerns. A fundamental consideration for testing a backflow preventer is to assess back pressure, which can affect the test results and have potential health and safety ramifications. Therefore, assessing back pressure should be conducted before evaluating the operational aspects of the backflow prevention device assembly. Regarding back pressure, the downstream shutoff valve should be closed before conducting the back pressure assessment. This approach lessens the possibility of compromised water discharging from test cock 4. The air purging from the pressure gauge used to assess back pressure should be dealt with in the same manner as flushing the test cocks. If the back pressure assessment revealed that back pressure is not present, the water discharging from test cock 4 is inlet quality. However, If back pressure is present, the water discharging from test cock 4 is compromised, and the downstream shutoff valve is not drip tight. Backflow prevention device assembly, notes flushing test cocks. Note 1. Caution should be taken when disposing of the water in the bucket, since it may be compromised. Test kit hoses should not be connected to test cock 4 when the downstream shutoff valve is not drip tight with back pressure. The connection of hoses can be viewed as a cross connection, and the compromised water from test cock 4 may cause harm to the backflow test kit. Note 2. The statements made in this presentation are based on testing the backflow prevention device assembly, utilizing the high and low pressure hoses to measure the differential pressure across the check valves, and to utilize the vent hose to conduct the no-flow validation test. Other test methods may address the concerns mentioned in this presentation differently.